Alright, welcome back from the break. So let me start from where I stopped last from the previous class. I did this and I said that in this class I'm going to show you as many things as what possible. So what is the first thing I will be showing you here? I said that an absolute value function is just like a machine programmed to do three things, one after the other. Let us take for example that in this machine now, this is a machine, this is a what? A machine. This is a machine. And inside this machine, there are some components that are built in this case, programmed to do one thing at a time. And a number, okay, here is input. You input a number here. Now, this number now is connected to the components inside the machine. So when this machine now is going to analyze this number that you put here, if the number is greater than 0, it will give you what? It will give you an outcome of, what? A. It will give you an outcome of what? A. If the number is equal to 0, it will give you an outcome of what? 0. If the number is less than 0, it will give you an outcome of what? Minus A. So let's take for example now that we put the number, the first number we'll put here now is 2. So now the absolute value function is going to process this. Since the number is greater than 0, our outcome here is going to be what? 2. You see, our number is positive. Let us try and put minus. Okay, let's try and put 0. Now, from the absolute value function definition, you see that here, if A is equal to 0, what is our outcome? Our outcome is going to be what? 0. So, we put what? 0. Now, let's try and put minus 5. Or let's try and put minus 2, don't worry. Minus 2. So now, what does our absolute value function say? It says, when the number is less than 0, your outcome is minus A. And mind you that your A is already minus 2. So what this will now do is what? It will come here and say, since it's minus 2, it's minus A. So this is what you are going to be doing. So now, it's minus into minus 2 to give you what? 2. So your answer is what? 2. So whichever way, that is why I said that the absolute value function is, in fact, they are not far-fetched. It is not far-fetched from what? The distance function. So here now, no matter what way, absolute value function must return the value positive. Do you understand it now? So this actually is the definition of absolute value function. So now I said that absolute value function is always greater or equal to 0. It cannot be less than 0. It is always greater or equal to 0. So now, let's just check something now. Let's say, find the absolute value of minus 2. What is going to be the answer? Now, say minus 2. This is equal to what? Check it. From this definition, it's going to give us minus sign. So now this is what? Minus into minus 2 to give us what? 2. So the absolute value of minus 2 is what? Is 2. What does this tell you? It tells you that you are moving left. You moved 2. Okay, let's say I am here now. And here is 1, here is 2, here is 3, here is minus 1, here is minus what? 2. Maybe this is the midpoint. And you moved 2 places to the left. Let's say 1, 2. And you have what? Minus 2. Or even if we not use this one itself, you know in number line, when you move to the left, it is what? Minus. Yes. So here is 0, here is minus 1, here is minus 2. So let's take for instance here, you moved 1, 2. So that is what? 3 minus what? 2. So it's still what? 1, right? So now this minus, when you put it in absolute value, you get what? 2. Meaning you moved 2 places. The distance between 3 and 1 is what? Is 2. So that is it. And When we start solving some questions in this absolute value function, you see that it is very, very what? Sweet. So let me try and do one thing before I switch over. So I find the absolute value of x if x is equal to 2 minus 4, 6, and 0. Okay, now after doing this, okay, let's do this one. This one is just simple. The absolute value of, so when x is equals to 2, absolute value of 2 is equals to 2. When x is equals to minus 4, absolute value of minus 4 is equals to what? 4. Now, I believe you can do the rest. Okay, now we say absolute value of x is greater than or equal to 0. Justify. Absolute value of what? X is greater than or equal to what? 0. Justify. Now, what is justify? Let us assume that it is true. So now, if it is true, you're not just going to tell us that it's true. You're going to what? Prove that what you are saying is what? Correct. And it is very, very easy to see from the definition of absolute value. When you want to solve this, now you can say from the absolute value definition, we see that that absolute value of x is what? X if greater than 0, 0 if equal to 0, and what? Minus x if less than 0. So now, to complete your justification, you will now say pick a number from the three pick a number from the three divisions. So we are going to first of all pick a negative number. When we plug a negative number, okay, let x equals to minus 2. When we plug a negative number here, what is it going to give us? It is going to give us what? 2. When we plug in 0, half got 0. When we plug it to a positive number, half got 2. So therefore, the absolute value of any number on the real line must give us what? A number which is greater or equal to 0. Greater than 0, this 2. Equal to 0, this 1. So for any number on the real line, its absolute value must be greater or equal to 0. I don't know if I'm making any sense. Please, if there's any correction you wish to give me, I'm open to correction. Just drop it down in the comment box below, and when I see it, I'm going to attend to it. Thank you, and do have a nice day. In our next class, we are going to be solving some example and doing some proofs. Thank you.